Hello and welcome back to my Keypad integration series. In the last video, we introduced the AT89C51 microcontroller, which is basically a full computer on a chip. It has an 8-bit CPU, 4K of ROM, and 128 bytes of RAM, but it also includes 4 8-bit PIA ports, peripheral interface adapter ports, that allows us to hook up to various items, to any one of the ports. To start off with, we had our keypad connected to port 1 here, and a single 7-segment display connected to port 0. In this video, we're going to add a second 7-segment display and connect that up to port 2. Now we could have both 7-segment displays connected to port 0 and use this port for multiplexing, but I just wanted to make this simple at first and figure out the code needed to display the correct numbers on each one of these 7-segment displays. In the last video, we had a single 7-segment display, and we saw how the AT89C51 would scan each row individually by setting one row bit low and then scanning each one of these columns to see if the low was felt at any one of these, and then it would go ahead and set this back high and set the next row low and do the same thing, check each column, and then it would display the correct 7-segment code on the 7-segment display over here that's connected to port 0. Now we're going to add a second 7-segment display and connect that down here to port 2. Now we have to just figure out the code that will work to allow us to, when we first press a key, that it shows up only here, but when we press the second key, that display will switch over to here and the new key pressed will show up here. So let's get into the coding. Now there really wasn't a lot I had to do as far as coding is concerned, but I did run into a couple of failures that I want to share with you. This is, again, the Kale, I don't know if I'm pronouncing that right, microvision program, and it's a great program to use. And it has this feature, debugging, so you can actually step through each one of your commands and see what's happening. So let's just go ahead and start that up here. And it also shows you all of your ports. Now we're only using port 0 for one of the 7-segment displays and port 2 for the second segment display, and we're using port 1 for the keypad. So let's get stepping through this program. The first thing you see is the org, which is going to tell the program to start at 0. It's also defining the table down at the bottom. The 7-segment display is our data pointer. And the first thing we're going to do is we're going to set R0 to 01. That was something I added. That's just going to be a counter to tell us when to put something here on the second 7-segment display. Now I'm moving 40 into P2, which is basically 7-segment display code for a 0. And you see that showing up here. And then I do the same on port 0, put a 0, so we have a 0, 0 in there, and we're ready to start scanning our keypad. And the first thing it's going to do is make sure all of these bits are set high, which they already are, but it's going to do it anyway. And then it's going to set the first row low. You can see that right here. Now what I'm going to do is I'm going to set simulate pressing one of the keys, which is the first column in the first row, which is the number 1. And it's going to detect that push and move 0 into AA and call the display program. Now this is where I have made a few changes. It's first going to check to see if our counter is at 0, and it's going to jump to display 2 if our counter is at 0. But you can see up here our 0 is 1, so we're not going to jump. Instead, it's going to add A to the data pointer, which is 0. We're adding 0 to the data pointer, so it's going to go to the first, number in our data pointer here and put a 79 in A. There's the 79 in A, and then it's immediately going to be moved out to port 2 and display on our 7-segment display. And there it is, the 79, which is 7-segment code for number 1. Now, it's also going to store that in R2 here, so that when a second key is pressed, that 79 will move over to here, and the new number will show up here. Now, here is where I added a long delay. That was one of the problems I had in the original program. I didn't have this delay in here, and every time I pushed a single key, it would show up on both 7-segment displays. And I couldn't figure it out because when I would run through the program, like I'm doing now, step through it, it worked perfectly. But we obviously needed that delay to fix things up. So I'm going to just step over each one of these delays and then step out and go back to scanning the port. So now you're going to see where are we at. It's going to check column 2, column 3, and column 4, and we don't have anything pressed yet. So now it's going to go to row 2, and you'll see that it'll set row 1 back to 0 and then clear port 2. Now, instead of column 1, I'm going to do column 2. So it's going to jump past column 1 and go to column 2, and then it finds that there is a key pressed, and it's going to go back down to display, and it's going to check our R0 to see if that's a 0, which it is now because it was, where was that? Oh, it was decremented right here at the beginning. So it's going to decrement again. Actually, it's going to go down to FF. But now it's going to jump right over to display 2, where I have it, where it's going to bring up the first number again by looking at, what was it? Column 1, or row 2, column 2, which is this 12 right here. So that'll go into the A register. There's our 12. And then it'll immediately be displayed out here on port 2. There's our 1 and our 2. And it's also going to store that now in R2. Oh wait, no, it's going to bring R2 in and put that out here. There's our 79. And then it's going to put a 1 back in R0, back in our counter. You can see our counter's FF right now. But it's going to put that 0, 1 back up there so we can start all over. And then it's going to return. Now it's going to find there's nothing on column 3, nothing on column 4. So it's going to go down here to R3 and set R2 back to a logic high and set R3 to a logic low. There's 2 going high and 3 going low. And in this one, we're going to select row 3. So we're going to step through. It doesn't see anything on column 1 or column 2, so it's going to column 3 and says, okay, there's something pressed here. So it's going to move 0A into the A register, which you see right there. And then it's going to call display again. Again, we're going to decrement the R0 counter, which is a 1, but we're not going to jump because it's looking for a 0. If it's not 0, then it's just going to continue through the program. So it's going to take that A and add it to our data pointer and give us 18, I believe, right here. So there's our 18 in the A register, and now it's going to display that 18 on port 2 here. There's our 1-8. Now it's also going to move that 1-8 into R2. There's our 1-8 and R2. And then we're back to the delay, which I will step over, step over, step over, and then step out. And we'll go on to the last number. And as you can see, where we at? Oh, It's not going to find anything on R3C4. So it's going to move on to row 4. It's going to set the bit on row 3 back high, and then clear the bit on row 4, and we're going to select column 4 this time. So it's not going to find anything on row 4C1 or row 4C2 or row 4C3. When it gets to row 4C4, it finds that we do have a key press. It's going to move 0F, the last number in our data pointer, into the A register. There's our 0F. And it's going to call the display. It's going to check to see if our R0 is 0, which it is. So it's going to call display 2. And then it's going to take that A, which it has a 0F, and point to the correct data pointer, which is the last one here, which is a 21. So you see that 21 go into our A register, and it's immediately going to go out on the port 2. There's a 21. And then it's going to take whatever we have in R2, that 18, and put it out on port 0. There's our 18. Then it's going to set our counter back to 0, 1 and start all over again. Okay. That explains just about everything, and you can hopefully you learned how to use these, how to debug and walk through the program and look at your ports to see what's happening on those output ports. So I also want to go over some of my epic mistakes here and show you the results of those. I'm not going to reprogram it, but I'm going to basically just walk through what I used to have. Before I didn't, this was a little lower. Before, when you pressed the button, it immediately went to move C and then to display that right on the output port. Then it would check to see if our R0 was set or not set, and it would jump down here to move R2 into P0 and then automatically display that in return, and then reset the counter in return. The problem with that was basically I didn't have this delay in here at all, and anytime you pressed a key, it would repeat. It would show up on both displays immediately. And when I debugged it, it didn't do that. It walked through it perfectly. Showed one on one port, one on the other port, and everything worked perfectly. And finally, I added the delay, and that fixed that problem where it was actually just showing the first key pressed on the first display, and the second key would move the first display over and show the new key on the first display. But even that was a bit of a problem, because there was just a split-second delay where, like, if I pressed 1, 2, the 1 would show up on port 2, and then when I pressed the 2 would show up on port 2, but the 1 would move over, and there was just that little bit of lag that you could see that was a bit annoying. I was able to fix that when I changed this around, kept the delay up here, and when display 2 hit, I displayed both ports simultaneously. It actually gets, so now when you press the second digit, both ports show up at the same time. So no delay at all. So that was wonderful. So let's take a look at the actual breadboard, and I'll show you some of these fails and then the end result, how it worked out. Okay, here's our new circuit with both 7-segment displays wired up. And this was the first program that I have burnt on this ROM chip right now that worked well when debugging, but when I put it into the actual circuit, it didn't seem to work so well. I'm going to do a reset here. Both 7-segment displays are at 0, and whenever I would push a single button, that number would show up in both locations, which really bothered me, because when I debugged the program, it ran perfectly. That's when I figured out I needed to add the display or the delay in there, and that fixed that problem. So let's unplug this one, pull this one out, and put our next ROM chip in. Come on, get in there. Now, this is after we added the delay. I'm going to do a reset. Now again, both 7-segment displays are a 0, and if I press a 1 and a 2, you can see it shows up correctly. But if you watch the this port over here, you can see just a split-second delay that was annoying me. You see that little delay there? That was annoying me. That's when I came up with the idea of displaying both ports during the display 2 portion of the program. So let's take a look at how that shows up. Okay, let's pull this one up and put the final version in. Okay, here's the final one where we're displaying both ports at the same time during the display 2 portion of our program. I'm going to do a reset here. Okay, both of our 7-segment displays are displaying 0. Now if I press a 1 and a 2, they show up at the same exact time. Much nicer. And a smoother transition. So, that's it. Hopefully learned something. If you have any questions, feel free to ask. And thank you for watching. Have a great day.